Alright, I'm just going to continue the difference between the problems that I did in that earlier video and the problems that we're about to do now is we've got this left side equals this right side. So we're not just simplifying, we want to show that, or we want to prove the identity. We want to show that this left side equals this right side. So in general, we're still going to stick to our plan of writing everything in terms of sine and cosine and looking for functions that are squared to use our Pythagorean identities. And also, you can manipulate both sides of the equation if you want to. Normally you can get by with just manipulating one side. So we're going to just pick the side that looks the most difficult, simplify it, and see if we can prove the identity or show that the left side equals the right side. So tangent of x, we rewrite that in terms of sine, and cosine as sine of x over cosine of x, and then secant of x is the reciprocal of cosine of x. And so this is just like when we've done before when we have a complex fraction, so I'm going to multiply by the reciprocal. When I multiply that by the reciprocal of that denominator, then my cosines are going to factor out, and I'm going to be left with the sine of x. And that's what I'm trying to show. I'm trying to show that that left side, which I've just simplified to sine of x, equals that right side, which is sine of x. So I've done that. Alright, same thing with 34. Alright, so I'm rewriting everything in terms of sine and cosine. So I've got cosine of x times over sine of x times 1 over cosine of x all over cosecant of x, which is 1 over sine of x. Okay, simplifying, I'm going to have 1 over the sine of x up top. I'm going to have 1 over the sine of x on the bottom, and I hope at this point you're done, because you're thinking anything divided by itself is 1, or if I flip this and multiply, those sine x's are going to cancel out, and that is 1. Okay? Alright, so 46. Let's look at 46. So 46, I'm going to not write everything immediately in terms of sine and cosine and get everything all jumbled up. I am going to look at my Pythagorean identities though. Alright, so you have to know these, but let's just take a look at them and see what's going on here. So if I'm going to pick a side, like I said, we're going to go with the most difficult side. Neither one of these is more difficult necessarily than the other, so let's just pick a side here. So I'm going to handle this left side over here. So I'm going to rewrite this using my Pythagorean identity. So the tangent squared of x. Well, the tangent squared of x plus 1 is secant squared of x. So if I subtract 1 from both sides, that means that the tangent squared of x is going to equal the secant squared of x minus 1. Okay? So that's just tangent squared of x rewritten with my Pythagorean identity. And then cotangent squared of x. Cotangent squared of x is going to be cosecant squared of x. Take that 1 across, minus 1. So I've got minus, and then I've got cosecant squared of x minus 1. Alright, so let's clean that up a little bit, and we've got the secant squared of x. All I'm doing to clean it up is getting rid of my parentheses, so I've got to distribute that negative. And when I do that, I've got my opposites there, and look, I've got secant squared of x minus cosecant squared of x. And that's what I was looking for. I wanted to show that that left side equals that right side, and when I substitute it in and simplify that out, that's what I get. So I'm done. Okay? Alright, I'm going to do one more. I don't see anything squared, so I'm going to go back to my general strategy of writing everything in terms of sine and cosine. So I've got 1 over the sine of x minus the cosine of x the sine of x, all over 1 over cosine of x minus 1. Okay, so we're back to our complex fraction, and I don't know if I talked about this in an earlier video, but I could go ahead and get a common denominator and put my numerator together, get a common denominator, put my denominator together, and then just have one fraction over one fraction and multiply by the reciprocal. Alright, I'm not going to do that here. I'm going to just stick to what we've done before, and I'm going to multiply every term by the common denominator of all of this. So if I'm looking at all this, I'm going, you know what? My common denominator is going to be the sine of x times the cosine of x, because I've got the sine of x here and the cosine of x there. Alright, so let's multiply everything by the sine of x times the cosine of x. Alright, sine of x, cosine of x, sine of x, cosine of x, sine of x, cosine of x. Okay? Alright, so my sines of x, both of those are going to cancel, and I'm going to be left with cosine of x. Going to cancel there, and I'm going to be left with cosine times cosine, which is cosine squared of x. And then on the bottom, my cosines are going to cancel out. I'm going to be left with the sine of x. And then here, nothing cancels out, so I've got minus the sine of x, cosine of x. Okay? Now, can I keep going here? Yeah, let's look and see what we've got up top. Up top, I've got a cosine that I can factor out. I factor that out, I'm left with 1 minus cosine of x. On the bottom, I've got a sine of x that I can factor out, and I'm left with 1 minus cosine of x. Well, that's all good, because now I've got a common factor in the top and the bottom that I can factor out, and I'm left with the cosine of x over the sine of x, which is the cotangent of x. And that's what I was trying to prove.